Closer.
Okay, mute yourselves, please.
Professor, I have a quick question before you start. Just to verify, we're not reading the leads, or is it on exam or no? Or we're just not?
No, like I said, this is not an EKG class.
Okay.
I mean, it'd take a long time for me to explain the Einthoven triangle, what the leaves are, which ones are positive, negative. It's just too long.
Okay.
So, again, this is not a telemetry class.
Thank you.
All right.
Watch it. Watch it.
All right, let's begin. Any question from the last discussion about the time?
No, Professor.
All right, so let's look at there are steps in interpreting a rhythm. But before that, let's look at the measurements first. There are only 3 measurements that you will need to remember because not all of them have the numbers on your textbook. So we know the P wave. The P wave is what again? What is the P wave?
HUO depolarization.
Okay, very good. Or that is atrial contraction. Let's skip the PR segment. Let's just discuss the PR interval. What is the PR interval again?
Atrial depolarization too?
No, PR interval.
Oh, interval.
The PR interval.
Isn't it the delay in pulses from the P from the
P
from
wave?
the S
Uh-huh.
from the P wave to the QRS complex?
Okay, Okay, so this is the impulse delay, meaning this is the time that the AB node took before it transmitted the impulse to the bundle branches. Okay,
Yes.
so that is, again, that measurement is between 12 to 0.12 to 0.2 seconds. Okay, so a minimum of 3 small blocks to 5 small blocks. The QRS complex, again, this complex is representing the
Ventricular depolarization.
polarization. Very good. QRS duration, this is the time, okay, of the QRS. This is measuring from 0.4 to 0.12 seconds. So only 1 to 3 small blocks. Okay. Again, the QRS duration, this is this time right here, the QRS is QRS duration only should last between 1 to 3 small blocks, or that's 0.04 seconds to 0.12 seconds. The ST segment must be isoelectric to be normal, but there will be changes later, which we will look at. Then again, the T wave is representing ventricular repolarization. They are not, the ventricles here are not contracting, but they are instead beginning to get ready for the next contraction. Are we recording? Yes, we are recording. Okay. Two people did not return yet. That's a long break. Okay. The U wave, which is not present all the time, we will disregard that because that will hardly show on most EKGs. I've only seen it very rarely also, so we'll forget about the U wave. So all I'm testing are the P wave, PR interval, the QRS complex and duration, ST segment, and the T wave. Any question?
No.
All right. The next
Can you
part.
repeat that, Professor?
I'm sorry.
Can you just repeat the ones you're testing? Sorry.
Okay, the ones on the test for which are important for EKG basic rhythm interpretation are the P wave, the PR interval, the QRS complex and duration, the ST segment, and the T wave.
Thank you.
Right, we have steps in doing that. So when you interpret a rhythm, say I give you a rhythm question, a rhythm strip. First step is to count the heart rate. It's very important to count the heart rate because that will determine, first of all, is this normal or not? So first step is to count the heart rate. I'll show you how to count it shortly. The next step is to determine the rhythm. Now this heart rhythm here, this is not to say you're interpreting the rhythm. Okay, you're simply determining the regularity or irregularity of the waves and complexes. Okay, I'll show you how again, or we'll do a practice shortly. 3 is P waves. First of all, why is the P wave very significant?
It will present the SA node, and if you don't have it, it means that the heart is not beating enough to provide enough oxygenation to the body. Like in order to have 60 to 100 beat, you need the P wave.
Okay, very good. So that's a good answer. The P wave is, as you know, this represents atrial contraction, right? Plus, if you see the P wave, you know that where did this impulse come from?
SA node.
The SA node. Okay, so that's the significance of the P wave. Next is measure the PR interval. Why is the PR interval significant again?
I think it causes the delay.
All right, so is that delay of the impulse transmission important?
Sorry.
Yes, it is.
Yes.
Okay.
If there's no delay, then will the ventricles fill with blood?
Yes.
Yes.
No, I mean if there
No,
is
it won't fill with blood. No.
no.
Well, properly at least. No.
Yeah, without the
Right.
delay, there is no ventricular filling.
Okay.
Next is the duration, and you know again the duration must be between 1 to. There's some discrepancy here on this part here. It tells you that the QRS duration is 0.4 to 0.12 seconds, and then down here it changed to 0.10 seconds. All right. For our testing purpose, because all other textbooks say 0.4 to 0.10 seconds, we will use this number. Is that clear?
Yeah.
Yes.
Okay. And then the ST segment, of course, this must be, this should be isoelectric. So questions on the exam will be, what will be possible causes if there is ST elevation or ST depression? And the details are here. So these are some causes of ST elevation, and here are some causes of ST depression. All right. Same thing also when you look at the QRS here, where when is it narrow, when is it wide? Okay. So please read these on your own. I won't discuss that. I won't read that for you. Is that clear?
Yes.
Yes.
Okay, so let's now do a practice. Before we can recognize dysrhythmias or abnormal rhythms, we should look at what does a normal sinus rhythm look like. All right, let's look at the EKG paper first. First of all, the paper has 3-second markers. In order for us to interpret a rhythm, there must be a minimum of 6 seconds. It has to be 6 seconds because it's impractical to do a whole 60 seconds. The it's not practical because first of all, our table is short. You don't have room at the nurse's station to analyze 60 a whole minute strip. It's way too long. Plus it's easier with a 6-second strip because you can simply analyze that 6 seconds and then multiply that by 10 equals 1 minute. With me so far?
Yes.
Okay. So this is a 6-second strip. How do I know it's 6 seconds? One. These are 3-second markers. This one right here, this one here, this one right here. These are 3-second markers, meaning between this and this is 3 seconds. Between this one and this one is 3 seconds. Don't believe me? Let's count. So if one big block is 0.2 seconds, let's count how many there are between this and this one. So let's count 1, 2, 3, 4, 5. That's 1 second. 1, 2, 3, 4, 5, 2 seconds. 1, 2, 3, 4, 5, 3 seconds. Agree with me?
Yes.
All right. So therefore, this is a 6-second strip. So we have 3-second markers here. So on your exam, all your test strips on the question will have these 3-second markers. If they're not there though, let's say your copy is bad, let's say that the copy didn't pick up the 3-second marker, you still simply just count the number of big blocks between that, and that will be your 6 seconds. Okay.
Yes.
All right.
Yeah.
So these are the characteristics of a normal sinus rhythm. The rate is normal between 60 to 100. The rhythms are regular. Now, step 2, which is the regularity or irregularity of the rhythm, we will need a caliper. A caliper is about $10. Plus, it's a tiny object. It walks. You put it down on the nurse's station. It walks. I mean, it literally walks. 1 second it's there, and next time you turn around, it's gone. I don't know why people like stealing calipers, but they do. At least in my experience. So I stopped taking calipers because I forget to put them in my pocket. So what I do is use a poor man's caliper, which is a piece of paper. So everybody get a post-it or whatever paper you have, and then put it against this rhythm strip right here. And I want you to mark your paper from this R wave here to this R wave. Okay, so get your paper and mark it. So I'm doing the same right now. And then move that to the next R to R. So you mark your paper from this R to this R. And then after you do that, you move it to this, to measure from this R to this R. Is it the same distance?
Yes.
All right, then move it again to this R to this R, and then so on. Are they the same distance?
Yes.
Right. Let's try the P wave. So without marking it again, use the same markers you already have. Measure from this P wave to this P wave. Is it the same distance?
Yes.
It's the same, right?
Yes.
All right. So what can you say about this strip's rhythm? Is it regular or irregular?
Regular.
Regular.
All right. So that's step 2. Step 3 is, what is the heart rate? No, sorry. What is the, are there P waves? Okay, so between this, on this, based on this strip, do you see P waves?
Yes.
Yes, there are P waves here. Do they look the same?
Yes.
Yes. Yes.
Okay. Next is, let's measure the PR interval. I'll try to enlarge this to see if it will look closer to for you. Okay, all right, this is the best I could do before without causing eye problems. All right, maybe you can still, okay, let's try. All right, I guess it won't enlarge. This will be the best I can do. Okay, we said the PR interval measures beginning from the P wave. So let's do this one right here, this guy right here. So this is the 1, 2, 3, the 4th R wave, P wave of the 4th R wave, this one. So this P wave started from this small block right here and then ends at this small block right here. So count the number of small blocks from here to here. How many do you see? I see 1, 2, 3, 4. I count 4 small blocks for this. Actually, it's 5. It's not very clear, but yeah, 5. It's 5 small blocks. So is it between 0.12 to 0.2 seconds?
Yes.
Yes, it is. So therefore, the PR interval is normal. So that checks out the third. So it met the rate. We'll do the rate shortly. So I know the rhythm is regular. The P waves measured, the P waves are present. They look normal. PR interval measures between 0.12 to 0.2 seconds, which is up to 5 small blocks. And then let's look at the QRS duration. Let's measure from here to here. Is it between 1 and 2.5 small blocks? Yes, this one measures exactly 2 small blocks. So is this normal? Yes, about all the QRS complexes here, the duration is between 0.4 to 0.10 seconds. So it's less than 3 small blocks. Is this normal?
Yes.
Yes, okay. So third step, we need to look at the heart rate. There are several methods to measure the heart rate. The basic one is to count how many heartbeats there are. So we said earlier that a complete heartbeat, lub-dub S1, S2, would be a PQRST. So if you have a PQRST, that's an entire cardiac cycle right there. So the fastest way to do this particular strip is, because it's regular, I can simply count from this 3 second marker here to this 3 second marker right here. So that's 6 seconds. So I will count how many heartbeats there are inside here and then multiply it by 10. And voila, I have my estimated heart rate. I say estimated because this is only a 6 second strip. For it to be accurate, I need to be counting a whole minute. But estimates are fine because as long as the difference is less than 10, that is acceptable. Okay, so let's try that first method. Let's count how many PQRSTs are between this 3 second marker and this 3 second marker right here. So let's begin. So do I count this one? Is it within the 6 second strip?
Yes.
Yes, so this P wave is well within this 3 second marker, so I can count this guy. Can I count this one?
No.
Technically, no, because this P wave is within this 3 second marker, so this is only half a heartbeat. Okay, for this to be counted, the 3 second marker must be around here in order for this to count. Since it fell outside, then I cannot count this one. So I can only count this up to here. So let's begin. 1, 2, 3, 4, 5, 6, 7, 8. So what is my estimated heart rate?
80.
About 80. But here it tells you what is the rate for this one.
87.
87 beats.
So is it within the 10 heart rate difference?
Yes.
Yes.
My estimate, which is 80, is acceptable. Now, because I don't know what technique or what method you will be using on my exam, you could be using this technique or the other 2 techniques that I will teach you. I have no idea which technique you'll use. So my choices will always be arranged. So I will say, I'll give you this rhythm strip, and my choices will be A, 60 to 70, B, 70 to 80, C, 80 to 90, D, 90 to 100. Fair enough?
Yes.
All right, because
Eh,
again,
What if I pick 70 to 80?
70 to 80, then that's,
Would that be wrong? Because 80 is a good estimate.
yeah, no, because because if you pick 70 to 80, then that means it will include 70. So
Oh, okay, I got you. Okay.
because it's not less than 80, it's 80 or more.
Okay, I got it.
So again, any violent reactions about that test question?
I
No.
don't think so.
No. Okay, so
No.
always go with the minimum, right?
Professor, can you just show again how you count it?
Okay. So the first method, which is ideal for rhythms like this, which is regular, you measured it using your poor man's caliper, your piece of paper. You know that this is a regular rhythm. And then so I can simply count the number of heartbeats, which is represented by a PQRST, between a 6 second strip. So this is my 3 second marker, 3 second marker, 3 second marker. So from here to here, I know this is 6 seconds. So I can count this because this whole entire heartbeat containing QRST fell within this 3-second marker. And this one, I cannot count this because only the P wave fell inside. The QRST are outside, so I cannot count this because this is only half a heartbeat. So I can only count this up to here. So if I count 1, 2, 3, 4, 5, 6, 7, 8, that is 8 times 10 equals 1 minute. So my estimated heart rate here is 80. Is that clear, Joanna?
Yes, thank you.
Alrighty. So the next method, okay. The next method is, remember we measured earlier how many small blocks and how many big blocks there are in rhythm strip?
Uh-huh.
Okay. So if one small block is 0.04 seconds and one big block is 0.2 seconds, correct? Yes?
Yes.
So how many small blocks are there in 1 minute?
300.
Okay, so there are 300 big blocks in 1 minute. How did we get 300? Divided by 0.2 is the measurement of a one big block. Divide that into 60, you get 300. What about small blocks? How many small blocks measuring 0.04 seconds are there in 60 seconds? Hello?
25.
What?
250.
No. 60
Oh.
divided by 0.04 seconds.
1500, right?
1500.
1500. All right. So we know there are 1500 small blocks in 1 minute and 300 big blocks in 1 minute. So you can use that method to count. So again, it is ideal for this type of rhythm. In fact, you can also use that for irregular rhythm because when it comes to irregular rhythms, there will never be an accurate heart rate because will the rhythm be the same from 1 minute to the next minute if it's irregular?
No.
No.
Not. Okay, so you can't win with irregular rhythms. So this one you can. So let's see if our measurement is the same regardless of the method we use. Okay, so in order to use the small blocks or the big block method, you need to count the number of small blocks or the number of big blocks between two R waves. In order to do that, to make it easier, let's look for an R wave that falls smack or close to a solid line. So which one do you want to use? R wave number 3, number 4, or number 8?
3 and 4.
Okay, let's see between 3 and 4. Okay, so Paul suggested we use this R wave here, number 3, and number 4 R wave. So let's count how many small blocks there are between these two. So I know there are 5 here, so I'll take a shortcut. It's 5, 10, 15, 19. Yes, no.
5, 10, 15,
15,
19.
19.
Yeah.
Yeah. Uh-huh.
Really fall on the solid line, but a little bit out of it. But this one also didn't reach the solid line, so I can say if I move this a little bit here,
Okay.
in here, so that would be 19, correct?
Yes.
Yes.
So divide 19 into 1500. What do you get? So 1500 divided by 19 small blocks. How much do you have?
78.9.
78.9.
Okay, so if you round that, will that reach 80?
80.
Yeah, so
79.
Within the 10 heart rate difference from the 87?
No, I don't like
Yeah.
that.
Yes.
80. Yeah. Yeah, it's still in the.
Uh-huh.
Okay. So let's try a big block method. So let's use this time R number 4 and R number 5. So how many big blocks are between R number 4 and R number 5? So we have 1, 2, 3, and shall we say 3.6?
Yeah, it's 3.6. Mhm.
Okay, so let's use 3.6 big blocks, divide that into 300. How much you got? Ashley, divide 300 by 3.6 big blocks.
83.3.
Let's use 3.6.
83.3.
All right. So 83, is that within the 10 difference?
Yes.
Okay.
Yes.
I rest my case. So on the exam, I don't know which method you'll use, whether you'll use the counting the PQRSTs or counting small blocks or counting big blocks. I have no idea what method you'll be using. So that's why my choices will be RB, 60 to 70, 70 to 80, etc. Any question?
No.
Okay.
Not yet.
Alrighty. So we know how to look at we just look at the steps, although we're not finished. We're only on step 3. So step 3 said we will analyze the P waves, but we did count the heart rate. We looked at the rhythm using our poor man's caliper. We saw that there were P waves. They were normal. They were consistent. We measured the PR interval, which measured between 0.12 to 0.2. We measured the QRS. And then let's look at the ST and the T wave. So same example. Is the ST segment isoelectric? Yes. So the QRS, the S here stopped right here, and then it rose from there to form the T wave. So is it elevated or depressed, or is it isoelectric?
Isoelectric.
It is isoelectric. When it looks depressed, let me show you what it would look like. If you have ST depression, it would look like this. So if this is your P wave, forget about that. Okay, so let's say this is your P wave. So an elevated ST segment, as Dr. Kudia showed you last week, look like this. That
I
is,
can't see.
oh, sorry.
Yeah, we can.
Always forgot this part. Okay, so let me start over. The elevated ST elevation would look like this. Oh, sorry. Oh, I have an eraser. Okay. So ST elevation would look like that. Okay, so this is ST elevation. ST depression, on the other hand, will look like this. So that's ST depression. This is ST elevation. Clear? We had examples in chapter 38, so please refer to chapter 38.
You said ST depression is the bottom picture?
Yes, and this is
Okay.
ST elevation. If you want to see examples of that, they're not
Okay.
34, they are found in chapter 38. One Dr. Kudia showed you last week, okay, because it's only found under acute coronary syndrome. Right, I have 4 minutes left, so we for 4 minutes. Any question?
No. Nothing.
Okay, so we did the steps. We did a good exercise. So we checked the heart rate. We looked at the rhythm. We determined the rhythm. We didn't interpret the rhythm yet. So step number 2 is just determine the rhythm, meaning this is referring to the regularity or irregularity of the waves and complexes. And then we looked at the P waves. And we looked at the PR interval. We measured it. We measured the QRS duration. We looked at it and saw that in the example we had, this was isoelectric, and then the T wave looks normal. So any question?
No.
Not
Alright.
at the moment.
So I'll see you again at 7:40. Please come back at 7:40. Okay, that's a 14-minute break.
Thank you.
Thank you.
Thank you.
Thank you.